Right, gentlemen, let us start with chapter 8 of PMBOK, that is about quality management. I'm sorry that last lecture on cost management was not recorded properly, it was corrupted, and that's why I could not upload it. I don't know what to do about it, but those who have attended, that is the only record we have, and we cannot upload anything from there. Yes, you can uh, take help from the previous lecture, but the previous lecture was partially in Urdu, partially in English, so probably for some of the people who wanted to refer, it might not be a very good option. But anyways, we today move on to the quality chapter, and here the process itself is not very complicated, but the concept is quality management is a very heavy concept, and it is much beyond the scope of PMI, because quality does exist beyond the project management. It does exist in operations, in systems. So quality is not only for the project. So whatever quality standards, quality procedures, quality methods you are already using in your organization, that is going to impact your projects as well. And the quality of project you want to upkeep would be subservient to the organizational policy on quality. So it is not independent. The project quality management is not independent. Remaining within the project management, we have just three processes. So it looks like a very simple game, but at least I can say that this is the translation of the whole quality management concept remaining within the confines of project. So there is a lot of complication within itself, because you need to have right concepts about quality while you are working with a project. We only have three processes, as I said, and these three processes are in first one is in planning, second in execution, and third in control. The process in planning is plan quality management. Naturally, whatever you have to do, you have to plan it thoroughly in planning, and we have to design what we have to, what are the standards of quality, what are the customer needs and requirements as per the quality, how are we going to assure and control the quality, and the mechanism, the tools, the measures, the metrics we'll be using for assuring and controlling would be decided in planning. So the quality management plan itself would encompass everything about the process and the product, which has to be checked from the quality point of view. Now, we not only have a quality management plan produced in this process of plan quality management 8.1, we actually have yet another plan which is to be created here, and that is the process improvement plan. This plan is needed for the purpose of improving the processes. If we find any fault, if we want to correct the method or procedure or the process through which the work of the project is being done, although we have planned in a thorough detail how the work of the project will be done, but whether that is how the work is being done, and also to see whether the method or process we have designed, is it good enough, can it be further improved, can it yield even better benefits. So it is part of the quality assurance that it finds if some process can be further improved, and when you find that a process can be further improved and can benefit the project, that has to be improved. So the process improvement plan will then come into play. So essentially speaking, process improvement plan have to do everything with quality assurance, but quality management plan creates both the plans for the quality assurance and for the quality control. Quality assurance will deal with the process of the project, and quality control will deal with the product of the process. Although there is a relationship between the product and the process as far as the quality is concerned, but there is no direct link between the two, except for that quality assurance can seek a lot of guidance by the defects which have been caught in the deliverable during quality control. So we'll talk about that. So quality assurance plan, as I said, would only be required in 8.2 perform quality assurance, but that is not all what we need there. We also need how to do the quality assurance, and that is part of the quality management plan. The metrics, the methods, whatever, tools and techniques and whatever we need to do to check the quality of the process or the work which is being done while it is being done. So that is quality assurance. Now, in 8.3, we will deal with the monitoring and control, and that would cover quality control, and quality control only happens for the deliverables. Quality control has absolutely nothing to do with the process of the project. It is just supposed to check and verify whether whatever the deliverable or part of deliverable is being produced, is it according to the quality specs, quality requirements, the tolerances. If it is all right, then we'll verify that product, that deliverable, and that would, after passing the quality control check, will become a verified deliverable. So what did execution do? Execution sent out our deliverable or a part of a deliverable, whatever it is, and that goes through the quality control, and quality control passes it, the inspection and quality control passes it. Only after that it becomes a verified deliverable. And you remember that a verified deliverable is then sent for further inspection, and that is for the user acceptance testing purposes. That is done in validate scope, which we have already studied, that after a deliverable, a verified deliverable passes through the scope validation and it is cleared, then it becomes accepted deliverable. Then it is no more to be checked. It is just to be handed over to the customer. So if at all customer needs to check that deliverable physically, that will be done in user acceptance testing or validate scope, because after a product has been validated, it is considered accepted by the user. But anyways, that is not the subject. Right now, we are here concerned about the quality control, which is quality of the product, the verification of the quality of the product, whether it is within the tolerance limits prescribed to it in the quality management plan. So, if I say that quality assurance and quality control are both part of the quality management plan, that would not be wrong. But the process improvement plan, which is created in quality management, in plan quality management process, also only deals with perform quality assurance, and it has absolutely nothing to do with quality control. For quality assurance, we do audits, and through these audits, we check the ongoing processes. Another important thing about quality assurance is this is the only process in whole project management which has the authority of checking ongoing processes when they are actually happening. You see, all other knowledge areas only do the postmortem of an activity which has just been completed. They cannot and will not and do not check uh, the work of the work of an activity while that work is happening. Only when that job has been done, that activity has been done, can we comment on the cost and time and all other things. But as far as the quality is concerned, we have to remain awake while the thing is being done, and this quality assurance has the power to audit any time anything about the processes which are being adopted and which are being followed. So these are the three processes, and I hope I have made my point clear. Any comments so far?
Everything is clear, sir.
Wonderful, wonderful. Adil Saab, is the voice all right today?
यस सर।
Okay, wonderful.
हेलो,
जी जी,
आपको आवाज आ रही है? तो मेरा तो
yeah,
ये म्यूटेड शो हो रहा
of course, बिल्कुल आ रही है.
है। अच्छा,
Okay, so let's move on. If the basic concept is on, then we can move ahead. The quality management includes the processes and activities of the performing organization that determine quality policies, objectives, and responsibilities. You see, that's what the management plan do. It covers all the policies, objectives, responsibilities, and guidelines and everything. But quality will cover only with respect to quality. The quality policies, the quality objectives, the quality responsibilities, so that the project will satisfy the needs for which it was undertaken. Project quality management uses policies and procedures to implement within the project context. You see, as I said, quality is a much larger subject. Rather, it is a larger than life subject, and that is not only encapsulated into a project, it is even wider than your organization. So, what we are talking right now only concerns the project, whatever the quality policy or quality management you are doing at the organizational or corporate level, those things are being inherited to you. You are adopting those practices. If you are a ISO certified company, then you are probably following those procedures which were being followed by the organization or the corporation. So here what we need to do, whatever we do, that would be within the project's context. Only within the project context. Anything beyond the project is not our responsibility. But whatever are the policies adopted by the organization in their organizational quality management system are to be considered and followed as appropriate to the project you are doing. Project quality management works to ensure that project requirements, including the product requirements, are met and validated. So here quality management plan is supposed to cover both the processes and the product, right? So quality management plan is not dedicated for quality assurance or dedicated for quality control. It is going to define the policies and procedures and activities and responsibilities for both of them, quality assurance and quality control. That means the quality of the process or work and the quality of the deliverable both are to be the responsibility of project quality management, and therefore will be covered under the quality management plan. Project quality management addresses the management of the project and the deliverable of the project, as I just said. Not only the work of the project, but the deliverable of the project. It applies to all projects regardless of the nature of their deliverable. You can't say that in this one project we just need to do quality assurance, no quality control is required. No, that is ridiculous. We need to apply the whole quality management concept on all the projects, whatever they are, big or small. Quality measures and techniques are specific to the type of deliverables being produced by the project. Different approaches and measures should be used differently on different projects. So that is exactly why you have to take into account what the organizational quality policy are and what are the recommended tools and techniques are, as if you can appropriately pick and choose what to do where. So all the measures and techniques available would be mentioned in the project quality management plan, what tools and techniques are to be used where and in what capacity. Failure to meet the quality requirements can have serious negative consequences for any or all of the project stakeholders. So you see, if you are not able to produce the quality product, or the work of the quality project is not of good quality, a lot many stakeholders will be put off, and we don't want to do that. We want to give them the satisfaction that they are dealing with professionals. Moreover, there is a widespread misconception that quality management means that it is adherence, quality is adherence to the standards. Well, I don't have a major objection to that. Well, yes, we do adhere to some kind of standards, but that is not the sole purpose of quality. If that be the purpose, then probably we would only be following the standard and we would not be considering the customer or the end user for for their approval. So, if it is according to international standard, if America vets that standard and they would take that product, then my customer should take it. How can I say that? And why should I say that? Why should there be one international standard and everybody is bound to follow that? For example, in Pakistan, if our people are not able to afford that international quality which we are so fond of, so probably they can't pay for it. And if I say that I am an ISO certified company and I'll give you this quality and nothing less, dear sir, our client is asking for a specific level of quality and we are supposed to fulfill that. We are not to refuse based on some international standard or whatever. Naturally, we would love to produce the best of the best. But the problem is the requirement from the customer may not be best of the best. Therefore, the main stakeholder here is the customer, and meeting customer requirements by overworking the project team may result in decreased profits and increased project risks, employee attrition, errors or rework. You see, we do agree that it is all about the customer, but at the same time, we have to draw a line. We have to reach an understanding up to what level. There should be a mutual agreement. What is the requirement of the customer? It should be mutually agreed. What standard of quality is to be delivered to the customer? If we don't set that, the customer will keep increasing their demands, and ultimately, quality, you already understand it is a continuous improvement cycle. So we will keep improving the product forever and we will never be able to meet the customer requirement because we have actually not determined the customer requirement. And customer is constantly increasing the scope of the project. Meeting project schedule objectives by rushing planned quality inspections may result in undetected errors, decreased profits, and increased post-implementation risks. Sometimes in project management, just to do the job faster, we skip the quality control or the inspections, or for that matter, we do not do them as religiously as they should be done, and thus leaving room for errors. And naturally, if there are errors, your product will not be acceptable. There would be a lot many risks you have to later on pay to fix. So why are we doing that? Why are we rushing the project at the cost of quality? No, we should not. We must also understand the difference between quality and grade. This is very common. We generally use these two terms synonymously, but quality and grade are not the same concepts. This is a misconception most of the time people carry. This is a high quality product. This is a high grade product. Can you really differentiate between these two? Yes, anyone? Can you differentiate between high quality and high grade? Anyone? Quality and grade.
Grade could be related to.
Yeah,
grade is like a kind of a potency of a product, like the function that it performs. Probably the grading is in that.
You mean to say that grade is the function? Grade is the function? That's what you mean?
Yes, in other way, yes. If it is to like the grading, but see, for grading again, it's a quality criteria.
Okay, that's exactly my point. We synonymously use quality and grade. Is it okay?
I guess it's okay, sir.
It is okay, right? Anyone else who differs from him? Adil Saab?
Can you hear me, sir?
Yeah, of course.
Acha, I think the grade is like to compare Toyota with Mercedes.
Okay.
मर्सिडीज का ग्रेड ही ज्यादा है, मर्सिडीज का डिजाइन लेवल ही हाई परफॉर्मेंस और हाई क्वालिटी मतलब हायर उसकी परफॉर्मेंस ही ज्यादा है, और जो आपका टोयोटा है उसका ऑल्दो दे आर मीटिंग देयर क्वालिटी क्राइटेरिया बट द क्वालिटी क्राइटेरिया इज सेट एट अ लोअर ग्रेड.
You mean to say that Mercedes has different functions or more functions?
नहीं नहीं, फंक्शंस की बात नहीं सर.
Hmm.
The level of quality by design for a Mercedes is better than the level of design that Toyota manages.
Okay,
Toyota का जो डिफाइंड क्राइटेरिया फॉर क्वालिटी है वो एक डिफरेंट है और उसको वो मीट
right.
कर लेते हैं, बट दैट ग्रेड इज लोअर देन द मर्सिडीज.
Okay. So, can you say that Toyota, Toyota, according to its grade, is of the best quality?
Yes, within the grade class it is the
Within the
best
grade.
quality.
Exactly. Ji, anyone who can comment on that? Mubin, any ideas? Ji, Mubin, we cannot hear you. Adris?
No, sir, not exactly.
Okay, fine. Shahid? Ji, Shahid, what do you think? What is the difference between quality and grade? Vasif, please.
Perhaps like we said, like category A, category B, and category C of various products. That perhaps that is the grading of the quality itself. The category A is related to a much high quality. Then we grade it to a specific range, make it to the C. You can see it is actually sort of the quality related to the deliverables that it achieves or the characteristics it has within it, and how successfully those characteristics have been achieved. If it's very successful, as per the requirement of the customer, we will get it to the A. If it gives a variance to its quality, make it to the C. We're actually grading the quality, you can say this.
Okay.
Characterizing, making it into characteristics of features, and there are many stuff going on that makes it into different categories.
Right. Okay.
Okay.
We have heard everybody. Yes?
Sir, you may say the grade is an item's classification based on its technical requirements, so the technical characteristics.
Grade is a technical characteristic. Okay.
How successfully it has fulfilled those characteristics.
While the quality is the degree to which any product or any deliverable fulfills the requirement.
Okay.
So yes,
With a little up and down, we are all somehow understand it, but we have a kind of twisted kind of a concept about it. First of all, quality is not grade, and grade is not quality. Absolutely no relation between quality and grade. All of you are somehow trying to relate the quality with the grade. as Adil Saab has said, you can have different grades and every grade can have its own quality. Every grade can be of best quality, but one is Toyota, one is Mercedes. So there could be a best quality Toyota and best quality Mercedes, because Mercedes and Toyota are not from the same grade. And which he did not, agree with me was the main difference. Grade is the number of features and functions available in a specific category. That is the grade. The number and features and functions. So, for example, let us take the example of a mobile phone. If you have a simple Nokia phone which cannot do anything, which doesn't have any number of functions, except for you can call out and in, that's it. You just can receive calls and make calls. That's all. That does the function of the phone. That has a very low functionality. Only receiving and sending the calls is the only functionality of that phone. But whatever it does, it is of the best quality. So this is an example of low functionality or low grade and a very high quality. So such a phone would be low grade, high quality. Let us take the example of another phone from China which can do everything in the world. It can receive calls, send text, photo message, picture message, video, camera, radio, TV, and what you can think of. There are 250 different functions which it can perform. So this is a high grade item. When you start making a list of its functions, that goes out to be 250. But the quality of this product is such that in none of the functions it tops. It is in the bottom few grades, bottom few marks in quality for each and every functionality. That makes it a disposable phone, affordable and disposable phone, which is a very high grade item but a very low quality item. So such a product would be called as a high grade low quality item. Now let us take the example of a high grade high quality item. What could be the example of a high grade high quality? Maybe nowadays Samsung or Apple could be treated as high grade high quality. They can do a lot many functions and they are pretty good in most of them. You see, as compared to the Chinese phone, a Samsung or an Apple phone would be high grade, high quality. And what you should not be focusing on is a low grade, low quality item. Neither you have good functionality nor any quality. So you should not go for that. Do I make myself clear?
Yes, sir.
But sir, don't you think the quality is what customer actually needs? If customer is looking for the same kind of level, the grade you about the Chinese mobile,
Exactly.
if the customer is looking into it the way it has fulfilled its requirements, and then it has a quality.
That's the first thing I said. That's the very first thing I said. It is not about
the love lies in lover's eyes.
Yes.
The love lies in lover's eyes simply. Then the quality is what the customer perceives actually.
Of course, that was my first point. That it is not about the international standards. It is not ISO which is telling us what the standard should be delivered in Pakistan. It is my customer which is going to tell me what they want. So whatever is acceptable to them, that is the level of quality wanted by them. So if people in Pakistan are happy with the quality of a Chinese phone, then it is okay with them. It is the quality
Yes.
they want. Yes.
Okay.
So for Pakistanis, if that assumption is correct, that people here in Pakistan only want that much quality and a very high grade, so that would be high quality, high grade for them. But you see, this is not the case. Only a small section of community needs that kind of phone, which is disposable, which is cheap, and which cannot be repaired, which does not have good quality. If it is not having good quality, it breaks down very often. Then probably we'll throw it out, throw it out, because the repairing itself would cost a lot, and therefore the low cost of that item helps, makes it possible for us to throw it away and buy another one. So this, if that is the quality required, that is only required by some people. These are people who cannot afford a high quality, high grade item otherwise, which is generally acceptable in our community. And naturally, you will agree with me that even in Pakistan, people are buying Samsung, people are buying iPhone. Why should they? That means there is a section of society which is high quality conscious. So if you take an average of your society in Pakistan, then you will find what actually is required by the people. Then it also deals with the section of society or target market you are targeting. If you are making phones only for the poor, then probably Chinese market is going to capture that area. That is good enough for them. But if you are targeting market for the people who ask for better quality, then probably we go for a high quality, high grade item. But these are two different points. International standard versus the customer requirement, that is one point. Quality versus the grade, that is another point.
So I have a question again. We normally say A quality, B quality, and C quality in the same product.
Okay.
Is it related to quality or the grade? What would that be then?
That would be various versions of the product with different specifications, different functionalities.
But if we have a jeans pant
Like,
and in single lot we said this is A, this is C.
actually, you
What would that be then?
see, we are misusing this word grade. Basically, grade would mean this is a pen which can write in blue ink, right? Say this is one function, and it can only write in red ink. If there is another pen which can write in red and blue,
Okay.
that would be another grade. So that should be compared from according to those characteristics for its quality. As far as the
Okay.
gradation is concerned, the the pen having two different colors is of a higher grade. But whether it can write well, is the flow of the pen all right? That would determine its quality.
Okay.
And
Okay,
who is
that's fine now.
responsible to determine what quality and what grade has to be there in the product? Again, naturally, customer is going to tell you, but at the same time, project manager and his team are responsible for managing the trade-offs associated with delivering the required levels of both quality and grade. Where do we, what is the level of quality we want to achieve, and which grade we want to acquire or produce. So this has to be decided naturally based on the customer requirements. While a quality level that fails to meet the quality requirements is always a problem, low grade of quality may not be a problem. Low grade of quality may not be a problem. If a pen is supposed to write only in blue ink and it writes in blue ink, it could be of good quality. You do buy a pen from the market which has an excellent flow and it writes in blue. Only blue. It cannot do 10 other functions. It only can write. So this is a low grade high quality item, and that does not pose any problem to you. That is good enough for you. Right. So this is what we were getting at. There could be high quality low grade item, low quality high grade item, or low quality low grade item. But what we are targeting in project management we want to produce high quality high grade item as much as we can. But naturally, project manager and his team will determine the level to which the quality and grade has to reach. If we have understood that, let's talk about another thing, accuracy and precision. Now, project management team should determine the appropriate level of accuracy and precision for use in the quality management plan. Now, let us describe what is accuracy and what is precision. Precision is the measure of exactness. It is the magnitude of each increment on the measurement number line in the interval that determines the measurement's precision. The greater the increment, the greater the precision. And accuracy is an assessment of correctness. How correct you are. Let me show this to you through this example. Okay, what do you see? You see 4 targets. They have been placed on one side there is increasing accuracy, on the other side there is increasing precision. Right? Okay. The lower two examples are of low precision. Is of low precision, where your results are not consistent. You see, in the alpha case, neither your results are consistent nor are they on target. In B case, your results are not consistent, but they are on target. Right? What does that mean? When your results are not consistent, but you are on target, that means that you do not have proper policies in place, and therefore what you produce is greatly varying. There is no consistency. But if you are moving in the right direction, you will be, meeting somehow the customer demand. On average, you will be meeting the customer demand, but your results are not consistent. You are unable to produce the same item consistently over the repeated attempts. On the other hand, if your processes are perfect, there will be consistency in your work. But how much aligned with you are with the expectation of the customer, that would put you off target. In C case, you are highly precise, your procedures are well thought of, well designed, consistent, but you are not accurate, you are not on target. Whereas in D case, this is the ideal scenario where you are not only highly precise but also highly accurate. You are consistent, all your tries, all your attempts are producing almost the same result, and all these results are on target. This is exactly according to the customer specification. Do you get this difference? Any comments?
It's okay, sir.
Discuss this.
It's okay, sir.
It's okay. Okay.
Yes, sir.
So what should your target be? That we not only need to be consistent. Meaning what? We need to be precise as well as on target. A very good example would be, you have a weapon you have a gun and you are firing on target. If you are good at making the target, if you are good marksman, you will always be on target. That is the effort which the individual is putting in. He is always on target. But if your weapon is not properly aligned, is not properly zeroed, no matter how good marksman you are, you will be off target. You see, the system, the weapon, that does not have the consistency, that makes you off target. Whereas the marksmanship is of course of excellent quality. In the lower case, there is no marksmanship. There is an average person firing the bullets. But if those bullets are being consistent, in lower case they are not consistent. He is not a good marksman, but he may be on target. The B example is of that the person is a good his weapon is well aligned, but he's not a good marksman. Otherwise, his bullets would have been closer, more consistent. So B represents good weapon, bad marksman. D represents good weapon and good marksman. C represents good weapon and bad marksman, and A represents bad weapon and bad marksman. Just now, replace the weapon as processes and the marksmanship as the product itself, the quality of the product and quality of the process. Okay, do you get me? Right. So internationally, we do talk about some kind of international standards. So these international standards do not bind us to international measurement scale. These ISO standards are just a general guideline as to the acceptability worldwide of the quality in different fields. So ISO has several standards coming out. Some are the quality standards, some are the healthcare quality standards, this quality standard, that quality standard. Those standards are a good guideline. Remember, ISO is a standard just like PMBOK. And standards are not mandatory. Standards are good practices. Standards are just a guideline as to how the thing should be done. But merely by the fact that you are following a ISO standard does not make you a company with good quality. First of all, ISO just certifies you as a company, and that says you are being consistent. Consistency, I just talked about, you are being consistent. So your consistency is established by following ISO standards. But that does not mean that you are meeting exactly the customer requirements. Your customer may dictate how well are you meeting his requirements. Every product should have a quality management plan. This is one of the needs of the ISO standard. Every process must be properly documented. That is another need for ISO standard. Project teams should follow the quality management plan you just created and should have data to demonstrate the compliance with the plan. If somebody wants to check it, how would you show it? That must also be given in the quality management plan. ISO just gives you good practices. It just tells you prepare a quality management plan. Do have processes. Do have metrics to as if you can check how well are you aligned with the quality management plan. In the context of achieving ISO compatibility, modern quality management approaches seek to minimize variation and to deliver results that meet defined requirement. And what are the defined requirements? Defined requirements are all about customer. Customer tells you what they want as far as the quality is concerned. NASA is not going to tell you. ISO is not going to tell you. Nobody can tell you what should be the requirements and what is the quality in the requirement. ISO is just a guidance which is just ensuring that you are creating a quality management plan, you are creating the processes, you are following that quality management plan, and so on and so forth. As far as quality is concerned, the world over, we have gone through a lot of changes over time. And interestingly, the main revolution in quality, quality has always been important, but you see, there was no realization of quality otherwise. Naturally, there was a vague idea. The poor people would have their own level of quality. It's basically the grades. The pharaohs of Egypt, they had their own quality. The laborers or the slaves, they had their own quality. So you see, these were the different grades, but there was no realization. Okay, it was actually after the Second World War, the thing actually came to some light. What happened after Second World War? Basically, most of the international resources went to war, and we had to leave off the normal routine of the life, and therefore there was shortage of a lot many things in the market. All the resources went into war. The men, material, everything. The whole thrust was on the war. So all capable men, all good resources and everything. And it was a matter of life and death. Whomsoever has a better technology or creates a better technology is likely to win the war. And war is, again, I will say, it's a life and death matter. And therefore, people were working overtime to win this war. This we normally do not have this kind of approach in our normal daily life. In peace, we are not fighting for our lives. Therefore, we are not working 24 hours a day because we are not fighting for our lives. So in war, your pace of development, the pace of inventing new things, coming up with new solutions is many times faster than the peacetime. Although there was shortage of things in the countries, but where the war was happening, the technology was developing as a very, very, very fast pace. What happened after the war? When the war finished, all these experienced resources, talented people, and all this technology which was developed just for war, they all came back home. And what happened at home? At home, they were short of resources. There was a lot of demand and no supply at all. A lot of demand and no supply at all. The food materials were not really available. People were just hand to mouth and things like that. But now a very skilled workforce is coming back home with new technologies, new inventions and everything. So these people, when they came back, they filled the need for those demands. They started creating the supply, not only the supply, but according to the newest technology they have just invented in the war. They converted that. They orientate their skills towards the civil life, and they started on the things which were in shortage. They started supplying for the demand. You see, that was a time when the only need was to provide food to the people or provide for their needs. Their demands had to be fulfilled. And when you are a beggar, you are not a chooser. So at that time, the people who were short of some items in their lives, they were not very choosy about them. If you are a poor man and you have not eaten for 3 days, will you be objecting to the type of bread is being given to you? I don't like this, I don't eat this. No, you are hungry. You will die if you don't eat. So your demand is filled by this supply, and whatever that is, you will just eat it up. You will just utilize it. So at that time, it was the quantity which mattered and not the quality. It was not the quality of bread, how round it is or how well cooked it is. It was only the matter of filling your stomach. And yes, yes, please. Ji?
Sir, sorry, I'm sorry, you muted. I thought you muted it.
Okay, okay, okay. Right. So what I was saying, right. So you see, in America, we saw that just by filling this supply and demand gap, there was something very important happening, not only in America but in the West, that they came up with the Industrial Revolution. And trust me, Industrial Revolution was the need of the day at that time, because there was so much of technology and invention, and there was so much of gap between supply and demand, that this Industrial Revolution was, the need of the day. But the Industrial Revolution focused only on one thing, that was to fulfill the demand, to provide the quantities, not the qualities. And initially, nobody complained. For many years, nobody complained because there was a gap between demand and supply. As soon as this gap started shrinking, people started becoming choosy. And they wanted, because they could get it from different sources. There was more supply than the demand. Now they had an option of pick and choose. They had an option of creating their own likings and dislikings. And now they used to reject certain items for a better item. That is where the story of quality over quantity started. Quantity was no more important, quality became important. So how did Americans react to that? They started implementing some kind of inspection or check and balance system, and that was kind of at the end of the factory. They used to put some people as inspectors, quality inspectors, and they used to control the quality, meaning what? No item which is not acceptable by the customer should pass out of the factory floor. That should be caught. So that was supposedly a very good way of ensuring good quality items to the customers, and Americans had been working on that theory for quite some time. No bad item should reach the customer, right? So how much were the bad items expected to reach the customers? Because if a single item from a reputed company, which is of not of good quality, reaches the customer can sue you, they can place liabilities on you, they can damage you, or there are a lot many things which could happen. So we didn't want to have that. So we placed quality control at the end of the factory, and we checked everything, and we ensured that only good items go out, and there is no complaint. And Americans were really happy with this philosophy. But there were two people. One was Edward Deming and another was Juran. They were basically Americans, and they tried to tell them that the times have changed. It is not the matter of quantity now, it is quality. And quality control is not the solution. But nobody in America or other parts of the world listened to them. But the Japanese were actually working on those kind of theories. They wanted to be the best. So what they did was they hired Deming and Juran. They brought them to Japan and listened to their theories, and started working with them. So actually these are the fathers of the modern quality, Edward Deming and Juran, and there are a lot many other Japanese scientists and social scientists who actually worked with these two guys and developed a lot many concepts on quality. And that concept is that it is not only the quality control which is necessary. Because what happens if you have a very strict, stringent inspection, quality control? What will happen? You see, if I produced 100 items in an hour, some will be rejected. And those who pass the test, they will be sent to the market. So, as far as the market is concerned, we have a good face to show that we only produce good items. But as far as within the factory is concerned, out of the 100 items we produced, only 50 items were passed. What do you say? Is it all right? Only 50 items passed, rest 50 items were defective. So should we be happy about it? Because our name is not going to be injured. But we are already causing ourselves a loss by creating 50 defective items which we are doing nothing to improve. Quality assurance talks about addressing those 50 items not by removing the defects, but by putting in place more stringent processes to ensure that these errors do not occur. Right? So there was a new emphasis on quality assurance of processes rather than checking the quality of the product. So emphasis has now been shifted from inspection to audit, or from quality control to quality assurance. And that was the basic Japanese revolution. Now, after that, there were a lot many things happening all around. People started talking about the quality assurance, and they were so married up to the concept of quality assurance that they completely forgot about the quality control. I remember people talking about preparing a quality management plan and forgetting about the quality control. Just quality management plan. We should have better processes. We should have this. We should have that. Fine. But if you are not checking the quality control, if you are not checking the deliverables, then you are equally at loss, because now you have improved your processes to the limit that out of 100 items, only 1 or 2 are defective. But those 1 or 2, if not checked through the quality control, will reach the market and will damage your repo. So I agree with you that out of the 50 items which are being rejected earlier, now there are only 2 items being rejected. So you have improved. You have saved 48 items from rejection, and you have been able to send them to the market. But out of these 100 items you sent to the market, 2 items have gone defective. They have reached market and they were defective. And when the customer will have them, they will have a very bad repo for you. They will cause you damages. This is even a bigger loss. So we cannot do away with the quality control. We cannot say that quality assurance, because quality assurance is the new wave, so probably it will handle everything and this is all what we wanted. This was about 10 to 15 years back. This was the sensation in the market. They were all talking about quality assurance and they were unable to understand. They were not ready to perceive that quality control is not gone. That is exactly why PMI is using the word quality management plan. The quality management plan has to be developed. which includes quality assurance as well as quality control. Both of these things are of equal importance. But if you have good quality assurance going on, then there definitely is no need for having a large staff for quality control, because now you will be producing less bad items and therefore few people can check it. So the money you have spent in quality assurance will actually give you dividends on the other end, but you cannot remove quality control altogether. So we have to do both. We have to do quality assurance as well as quality control. And not only that, we also need to learn from the mistakes we are making. The defective items we are creating, we have to go back and fix them and thus improve quality further. I mean, you have to find the fault with your processes and make sure that this kind of flaw will never occur again. So actually Deming worked on a lot many things, and the biggest thing amongst them was the continuous improvement, the Deming cycle, the plan, do, check and act cycle, which we said we do the planning iteratively, or the processes can improve continuously forever. He also gave the concept of zero defect. That, you know, Americans were very fond of using standard deviation, and they used to say 99.74% is a good quality. But Japanese changed the concept. They said no, that doesn't work for us. We go for zero defect. There should be absolutely no defect coming out of a system. No defective items at all, which look ridiculous. How is it possible you can be so sure there is no ideal machine? How can you be sure of zero defect? But the idea of zero defect came from Japan. And Americans did learn that Japanese products were getting better day by day. And then they had to look back at their own system and see, why are we not better than the Japanese? Why is the quality of Japanese even better than us? We just keep making fun of them that they are talking about zero defect and zero defect is not possible, and therefore we have just assumed that they cannot produce better than us, but they did. That means the limit Americans had in their mind of acceptability was to be further enhanced and improved. And the Six Sigma is the ultimate answer to that, which Americans think that they have found the solution. You see, when they talk about zero defect, Japanese, they do not talk in hundreds. The items rejected, they don't check in 100. 2 items out of 100, 1 item out of 100. No, not at all. They talk about millions. They say zero defect in a million. So when Americans saw that Japanese manufactured cars and everything, they are being more popular even in America, better than the American products, then they started thinking where can they improve? And they found that their 99.74% was the problem. They were accepting 99.74% as good, but 0.26% means in a million they are ready to accept about 65,000 defects. So they said this is too big. China and Japanese are talking about zero defect. We are having 65,000 defects. So where do we stand? We are no good. That is why Japanese products are better than us. So they started working on the theory how to improve it, and they found that three deviations of standard deviation, 3 deviations plus and 3 minus are not enough. They are just giving us the accuracy of 65,000 defects. So they started working towards the 4 sigma, 5 sigma, 6 sigma, and ultimately at 6 sigma they came up with a very magic figure, and that is 3.4 defects in a million. And Americans think that they have hit the jackpot. 3.54 is a magic figure, and right now worldwide they are using Six Sigma as their standard, and all their methodologies, quality management, tools and techniques, they are tailored around achieving Six Sigma. But trust me, Japanese still differ with them. Japanese still say zero defect. You see the difference? There is a joke about it. You said there was once an American company ordering some items from Japan, and they said that we will not accept anything less than Six Sigma. They said, what is Six Sigma? They said, out of every million items, we will not accept more than 3.4 defective items. When the delivery date was close, it was to be delivered in America. The president of that company, the Japanese company, he flew with the order to America, and he said that I wanted to be present at the time of delivery. They said, it's great, but there was no need. Why did you come? He said, no. I need to know what will you do with the 3.4 defective items, because we don't make any defective items. We had to create 3.4 defective items against every million to satisfy your demand. Got it? So Japanese are still better than us. They are still better than us. Anyways, so these are various people who have worked on various theories on quality. Customer satisfaction definitely is the prime thing in quality management. Whatever we are producing, the basic purpose is conformance to those requirements and fitness for use. And whose requirements? This is the customer requirement. Customer will confirm these two things. Whether the thing you are providing him does conform to his requirements or not. And secondly, is it fit for use? So this is all about customer. This is not about some international standard or ISO. Then we learned from this that prevention is better than cure. Prevention is better than inspection. So a renewed emphasis on quality assurance rather than on quality control. So it is previously people used to think that we just have some inspection team which will ensure that no mistakes go out of the factory floor. That would be the quality. So they were just inspecting the system. They were not taking any measures. Now quality means that quality has to be planned into the system, designed into the system, built into the system, and inspection is not sufficient. So if we are trying to build quality into the system, that will actually cost us extra. You see, maybe we want to ensure that our people are professionally trained. They have developed their processes. They are properly documented. They are following those processes. They have proper training and guidance and coaching throughout the session, throughout the production. So these things do matter. These things are measures which are preventing the mistakes, and we have to spend some money onto them rather than correcting the mistakes. If I spend money on putting the things right, that would be correcting the mistakes. Okay. Then is the cost of quality. Cost of quality, as probably I have mentioned earlier, this is the balance between the prevention cost and the cost of poor quality. That is called the mistakes we have done, the loss we get out of those defective items is the cost of poor quality, and the measures we take not to do something bad, this is the cost of good quality. So there should be a balance between the cost of good quality and poor quality, and therefore we should, you know, spend that much money only. We cannot spend indefinite amount of money in a project on quality, because quality is continuous improvement, and continuous improvement has no limits. But our project is not limitless. Our project has to end somewhere. So the first process, as I said, was quality management plan. How is it prepared? The process name is plan quality management. And here we need to have the project management plan, the stakeholder register. Naturally, we are talking to the stakeholders, collecting requirements from them. I'm here talking more about the quality requirements. We need to have risk register. If there are some risks and that affect our quality, probably we have to take that into account. Requirements documentation, enterprise environmental factor, and the organizational process assets, they are required. And then we have got a number of tools. Cost benefit analysis we have already studied in the chapter of cost. You know, you remember those net present value and this and that, IRR and ROI and whatever. So actually, whenever you make a decision for any kind of investment, no matter it is a quality investment, quality assurance, investment on some quality assurance measure or quality control, whenever there is to be made a decision, you have to check the feasibility of that decision, and that can only be done through the cost benefit analysis. Cost of quality I have just mentioned to you. This is the balance between the cost of good quality and poor quality. Then we have got 7 basic quality tools, which I'll talk about. Then we have got benchmarks. Benchmarking. Anyone who can explain to me what a benchmarking is? Yes, please.
So benchmark means we have set some standard, means we have to follow that one. Means, for example, like for manufacturing of vehicles, we have fixed some benchmarks for the quality measurements. So like it's actually
Gigi.
Actually, benchmarking is to compare one business process and performance. The best among the best would be taken as a benchmark that okay, we need to complete that
Process. Okay.
Benchmarking is like measuring rod.
Measuring?
Simple. Measuring rod.
A measuring rod. Okay.
Simple.
Right. If you think that, who sets this benchmark for you?
So the industry sets a benchmark normally.
Industry sets it for you. What is the interest of industry in you?
Industry does not set it for you, but rather industry के अंदर एक benchmark चल रहा होगा किसी particular attribute
वो कहाँ से आता है?
का पास average out करके रखती हैं, so as to be used for any of the new upcoming industry to be used as a benchmark.
Okay. So how do you see जो बाकी लोग हैं, whatever you are saying, this is very different from what Adil Saab is saying. ये तो कह रहे हैं कि ये कोई इंडस्ट्री से कहीं से आते हैं बेंचमार्क्स, बट व्हाट आई अंडरस्टैंड फ्रॉम यू, आपने तो कुछ ऐसा कहा कि हम खुद कोई बेंचमार्क कहीं से उठा के ले आते हैं, अपनी प्रोसेस में से कोई बेंचमार्क निकाल लेते हैं, या हम खुद कोई सेट करते हैं. हाउ डू यू इक्वेट टू दैट?
सर इंडस्ट्री लीडर्स से बेंचमार्क्स निकलते हैं, मतलब
इंडस्ट्री
benchmark.
ठीक.
Industry create benchmark. Like yesterday, we read the bank rate. The bank rate was a benchmark.
Sir,
plus minus
why should industry be concerned about creating a benchmark for you? Why
It's a
should
business environment basically.
A basic standard, so that the and E is for you. You can say E, or you can say the benchmark, the way you measure it.
Mhm.
There's a standard that you can use for starting anything, and then you can go plus minus from that.
benchmarks are
It
not
does not mean the benchmark is benchmark doesn't mean that you are going to follow it. You can go plus minus to it.
सर बेंचमार्क कोई स्टैंडर्ड नहीं होता बेंचमार्क
Sir, then
ना ही इंडस्ट्री को कोई तकलीफ है कि वो आपके लिए बेंचमार्क बनाती फिरे
sir, like if you are following some quality and the Levi's is the best.
हाँ जी
If you are making pants, pattern pants, people say Levi's is the benchmark. Means everything comes from the Levi's then.
everything comes from
Levi's quality, their standards and whatever they are following.
आई डोंट थिंक सर कोई किसी को डिफाइन करके देता है बाहर से, कोई एक्सटर्नल फैक्टर जो है वो आपको बेंचमार्क देता खुद नहीं है.
हाँ जी
बट द पॉइंट इज वंस यू आर रनिंग इन इंडस्ट्री यू वांट टू क्रिएट, फॉर इंस्टेंस आपको पेंट मैन्युफैक्चर करना है.
ठीक है
तो पेंट मैन्युफैक्चर करने का एक इंडस्ट्रियल स्टैंडर्ड आमतौर पे जो कस्टमर एक्सेप्ट कर रहा है, कस्टमर एक्सेप्ट करता है फॉर इंस्टेंस 5 ईयर ऑफ ड्यूरेबिलिटी. और जो आप बनाने जाएंगे पेंट, आपको अपने आप को अगेंस्ट द इंडस्ट्रियल बेंचमार्क, यानी कि कस्टमर की जो एक्सेप्टेबल लिमिट बताई हुई है आपको, एक तरह से मार्केट ने बताई हुई है कि जी 5 इयर्स का जो है ना ड्यूरेबिलिटी वो बेंचमार्क है एटलीस्ट. तो आप जब क्रिएट करना शुरू करेंगे तो इन द फर्स्ट ईयर यू मे नॉट बी एबल टू क्रिएट अ 5 ईयर ड्यूरेबल पेंट, but slowly and gradually you will raise your internal benchmarks to meet the industrial or the customer norms that are available in the market. तो
इसका
आहिस्ता आहिस्ता अपनी बेंचमार्किंग करके लेके जाएंगे आप उस लेवल तक.
इसका
So I
मतलब
think
तो ये
that is
हुआ that means that there are some international standards and international standards we know they are not mandatory. Then are you raising your standards only to meet the international standard? How can you compete in the market? If you are just good enough, how can you compete in the market? What you need to do is you have to rise above the international standards because you want to compete. That is the key. You are good enough, you are already following some kind of standard, you are abiding by all the international standards or whatever, and now you need to compete and be the best. To be the best, you have to see who are your competitors in the market, who are in the people who are better than you in the market. And for that, yes, I do agree, you can find a lot of studies conducted in the market. There are many bodies which conduct the studies and find out various parameters in which various organizations are doing good. Now you determine your own parameters from those, and then you benchmark yourself against your competitors. Remember, you always benchmark against your competitors. Nobody benchmarks you for anything. Industry may have studies to give you the good practices, but it is you who will decide who are my competitors and why are they better than me in what area, and who are the people I want to beat in what capability. You set your own benchmarks. You say Nokia is better than me because they give better quality of sound. Their better quality of sound scored 8 marks out of 10, but my system secured 6 marks out of 10. I need to beat them, so my benchmark is to beat 8. And if I do that, then in this feature, I will be better than Nokia. So I set a target for myself. This is my one benchmark. So I can set a number of benchmarks, and these benchmarks may be from the different competitors. And if I am beating 10 competitors in 10 features, then the product which I am going to be producing is going to be the generally the best. That way I will make my mark in the market. That is how we talk about benchmarking. Benchmarking is comparing yourself against your competitors and setting a line for yourself to achieve. What is your opinion?
Got it clearly, sir. अब समझ आ गई exactly.
Wonderful. So why I explained it, because most of the people I talk to, they have the same answer. Benchmarking is a standard. Benchmarking is given by the factory industry. No, benchmarking does not come from the industry. Yeah, you can have some standard, you can have some guidelines available how to do the benchmarking, but you do your own benchmarking and you do it against your competitors, not someone else's competitors. Then there is another method which is called design of experiments, and design of experiments means that there is something you can do in 5 different ways. How would you decide which is the best way of doing it? By experimenting with all those methods, right? So if you have to bake a cake, and what are the parameters in baking a cake is probably uh, what kind of dough you are making, uh, what kind of pot you are using in which you are baking this cake, how much time you have to bake it, and how much temperature you have to give it. For example, these are the 4 different variables, and with a different combination you can have a different kind of taste. You have to see which is the best, which will be accepted by the customer. So you will do the experimentation and then get it checked from the people which is getting the maximum number of votes, and that would determine that your product will have this kind of assembly. You see, there are a lot many products in the market which they have benchmarked themselves against others and they have improved their product in a specific way. There is a secret formula in there, like Coke has a secret formula, right? So it is encashing only based on that secret formula for more than 100 years now. So this is how you do the design for experiment and find the best way to make money. Then if the sample size is too big, you cannot do the destructive testing of all the sample. If you are manufacturing biscuits, you can't open all the boxes of the biscuits to check how they taste. You just have to sample. So the statistical sample would be a random sample of some certain predefined percentage. Only that many boxes will be opened, and that would stand for all the boxes which has not been opened. So you will do a select sample testing, and this is called statistical sampling. And we can use other quality planning tools as well, and we can conduct meetings, and resultantly we should come up with a quality management plan, a process improvement plan. We should have the quality metrics, how to check the quality of the product, how to measure, what is the scale, like somebody was saying a scale to measure. Then a quality checklist, which features are to be there and not to be there. Okay, cost of quality, I want to show you this diagram. You see, as I said, there is a cost of good quality. If you want to ensure that no mistakes occur during the work of your project, you have to spend some money in the cost of good quality, or we call it the cost of conformance. There are 2 parts of it. One is called the prevention cost and the other is called the appraisal cost. Prevention cost is the measures you take which will ensure that errors do not occur. You provide good training to your people. You document all the processes and train your people on that as if they be able to consistently produce the same product in the same way. You standardize the equipment, or you do the time to do it right. You practice. So all this money which is being pumped into is the prevention cost. This will help us not commit the mistakes. Then we have got the appraisal cost. If I am ignorant about the quality, I will not ever test anything or do any inspections. So because they cost, the testing, the destructive testing loss is there, the inspections are there, we have to pay for that. So the money being spent in appraising the system is your cost also towards the good quality, that is the cost of conformance. This is if we take this measure, we spend money in cost of good conformance, good quality, then probably our rejections will be minimized, our product losses will be minimized, but not completely eradicated. For that, you have to look at the cost of non-conformance or cost of poor quality. What happens? You may have an internal failure or an external failure. Internal failure means that while you are inspecting the product, some of them fail to meet the criteria and they are rejected by ourselves, by our own quality control team. So those items which are rejected, they are either scrapped or they have to be reworked and reinitiated for the market. They have to again be quality controlled. So both ways we have spending money on it. So this is the internal failure which does not harm our reputation. But if a single item goes to market bypassing the quality control test and it is caught by the customer, they may impose liabilities on us. They may, we may have to provide them warranty services, and sometimes you lose business. You see, if you go to a restaurant, they do not serve you well, they have lost the business. You will never go there again. That is a lost business. So these all are external failure costs. Now you can spend as indefinite amount of money in either of these boxes: good quality or poor quality, conformance or non-conformance. But because these are in the continuous improvement is infinite in session, and therefore it is impossible that you can spend indefinite amount of money. So you have to draw a line, and you also have to strike a balance between the cost of conformance and cost of non-conformance. So you have to decide that this much money will be spent on the good quality, and that would be how much money you are dedicating for the prevention, appraisal, and all that. So this you have to decide. This is the cost of good quality and cost of quality. Then we have got 7 quality tools. I'll just skim through them. First of all, we have the cause-effect diagram. Cause-effect diagram is a very useful diagram to hunt down the cause of the defect. You see, if there is a defect caught by quality control and this information can somehow reach quality assurance, this information we do provide this information to quality assurance. Quality assurance will try to dig down the reason for this flaw or this defect, and they will keep digging it down to the source, and once they have found the source, they'll fix it. So this is called cause effect diagram, and basically this works like this, that whatever are the major defects, you try to find which is the major cause of them. So it is just like a fishbone diagram, like it just looks like a skeleton of a fish, where the backbone is a major defect and the various reasons which could have caused it, major categories of reasons, they could be the bones on the spine. So there could be this flaw could have been due to the material, could have been due to the environment, personnel, method. So first of all, you determine which to blame. For example, you say this is the fault of the machine. Okay, fine. Then dig down into the machine, find the bones within the machine and try to pinpoint which machine. So you will open up the machine and list down all the machines which are there and try to pinpoint the machine which could be responsible for that. Then you will open up that machine and find that part of the machine which could be causing the problem. And ultimately, you will reach at that level where the problem can be fixed. This is a good example for that. There was a problem in the hotel reservation. So you found out that this is due to the environment. And there were three things which were affecting the environment. One was the noise and restriction, other was lighting, and other was required formal footwear. When you dug down in each one of those, you can ultimately find the even not only the root cause but the solution. For example, in noise and distraction, it says it is due to the lobby layout, and lobby layout is due to the insufficient soundproofing. So if that is the problem, then if we can somehow soundproof the system, our problem is resolved. Or maybe it is due to the lightning. And why is it due to the lightning? Lightning problem is due to the glare coming from the overhead halogen lamps. And why is the glare coming? Because there is no filter or screen installed on the overhead halogen lamps. Therefore, if the filter can be installed or screen can be installed, our problem is resolved. You see, we can dig down to that level where the solution of the problem can be apparently visible. So this is very important tool for fixing the problems. Then we have got the flow charts. If we have documented processes, we can see how the things are happening in our organization, how this process is working. Okay, we'll do this and then this step and then this step, and you can track down on this flow chart and find out where the problem actually occurs, which is the bottleneck, and you can fix that. Then we have the check sheets. Check sheet is just like a checklist, which you have to check whether these elements have been fulfilled or not. This is normally used for quality control, and quality control will use this check sheet to check those elements for quality control. Then you have got histograms. This is a very interesting tool. Histograms, you see, you have decided to check all the defects coming to you. You have categorized them into, say, 5 different boxes. All the defects due to insufficient time, all the defects due to management direction, all the defects due to process documentation, and so on and so forth. We found that there were 22 defects from insufficient time, 3 defects due to management direction, and so on and so forth. If you can somehow create a vertical bar, it will represent the size visually available to see for everyone, and you can easily say that biggest problem is process documentation. Because if I fix that, 30 defects will go away. So similarly, you can visually see which is the biggest problem. But this is not all. The next tool is a fabrication of this thing. What we do is, that is called Pareto diagram. In Pareto diagram, what we do is we sort these categories into a sorted list where highest number of defects come first, then second highest, then third highest. So process documentation was the biggest problem. So that was 30 items. So I put it first, then 22, then 16, then 3, then 3. And if somehow I can create a cumulative graph, 30 plus 22, 52, plus 16, 68, the line which will cause the graph which will occur would be something like the thing on background, the curved, white background box shape in the background. That shows that the maximum number of defects are in the beginning. And if I can fix the beginning problems, I will have most of the defects resolved. So better not to address those categories which are of least value, like system failure and management direction. We should not start correcting them first. We should start correcting the biggest problem first, as if we can have greatest advantage to be achieved as early as possible. Pareto diagram also has a law behind it, and that is called 80-20 law. 80-20 law says that 20% of the problem, 20% of the reasons are responsible for 80% of the problems. Meaning what? 80% of defects are due to 20% of reasons. So if we look at the categories, 20% of the categories, if I can address, probably I will be able to fix 80% of the defects. So we should address the highest value categories the first and achieve greater benefit in shorter period of time. Then we have got control charts. Control chart is something we'll be using later also in quality control and everywhere. That is the tolerance limit. You see, we have a specification, a functional specification for everything. I say the length of the table should be 3 feet long, but how exactly should it be 3 feet? I have to describe that this is the maximum plus or minus from the length which is acceptable to the customer, and this I have to agree with the customer that it could be 0.003 millimeter plus and plus or minus, which if within this range, upper and lower control limit, you will accept the table, you will accept this length. So this is called the tolerance. The tolerance is between the upper control limit and the lower control limit, and anything beyond that, plus or minus, is rejectable. So all the readings falling within the upper and lower control limits are within the control, are within the tolerance. Now the interesting part is how quality assurance can use it is, you see, there has to be a random pattern within the tolerance limit, right? Because this is by nature. But if this random pattern starts becoming, creating a shape, maybe one item has a reading at one item is here, second is here, third is here, fourth is here, fifth is here, sixth is here. That is almost making a straight line. If you feel that some pattern is emerging from this randomness, then there is something wrong with your system, and soon your readings will go out of control. No pattern should form here. It has to be random. So the standard rule here is 7-point rule, meaning if the 7 points occur simultaneously or consecutively on either the positive or negative side towards the upper or lower control limit, 7 points, consecutive 7 points, if they occur on the positive side or the negative side, that means there is soon to be a problem which will start rejecting, which will cause the start of rejection of your items. So you must immediately dig down and find where the problem is occurring, which of the parts of the machine is starting to show indications of abnormality, and you find that maybe through cause and effect or whatever, and fix that. So this was the control chart, and the 7th tool is scatter diagram. Scatter diagram is nothing. This is just a simple way. Scatter diagram is the XY graph. I hope you all understand XY graph. XY graph is on x-axis you show one variable, on y-axis you show another variable. If there is no relationship, all the points which will be plotted on this XY graph will be will not form any shape, and they will be a scatter. There will be dots, here and there. If they form a shape, then it means X and Y has some kind of relationship. So to establish the relationship between two, how X is affecting the Y, we have to see that. If X increases if Y increases as the X increases, that means X and Y are proportional. If the increase is equal, we say X and Y are directly proportional. If Y decreases as much as the X increases, we say it is inversely proportional, and so on. So we can have many deductions coming out of the scatter diagram. So this is called, in the XY graph, the traditional XY graph is called a scatter diagram. Benchmarking I have already expressed, design of experiment, statistical sampling. Okay. Then is the quality assurance. In quality assurance, naturally you are responsible for checking the quality of the ongoing processes. And as I said, this is the only process which deals with ongoing processes. No other process of even control deals with what is happening. So this is a live audit of the work you are performing. So the main tool is quality audit. And then you also use process analysis, because processes are being analyzed for any flaws. And all the quality management tools and the quality control tools may also be used here. So we will need quality management plan, the process improvement plan, which we created specifically for this purpose, quality metrics and quality measurements, and the project documents. And ultimately, if there is a problem, to fix that problem, we'll move the change request, and project management plan, project documents, and organization processes may be updated in light of that. Last but not the least is perform quality control. And that is about what? Quality control is about?
Deliverable.
About the deliverable. And this is done through inspections. So you can specifically see the tool inspection. Anyways, you have the project management plan. You don't need the process improvement plan. You need quality metrics, quality checklists, work performance data. In every control we have this. This will have to be analyzed, and ultimately quality control measurements will be coming out. Work performance information will be coming out of it. Where is that? Number 4 in outputs. So work performance data after analysis goes out as work performance information to monitor and control project work. Then we have approved change requests. All the change requests which have been approved from what? From integrated change control. All the change requests, they could have been moved from anywhere. Those change requests which have been approved, a copy of them has been sent to execution as if they can start performing. But a copy of those approved change requests also comes to quality control, as if quality control also knows what to check. It reviews these approved change requests. This is the 4th tool in tools and techniques, and ultimately the validated changes, those changes which have been reviewed and inducted into the quality control are sent out as validated changes. Similarly, the main job of quality control is to deal with the deliverable. So deliverable is coming as input. In tools and techniques, number 3 is inspection, and number 3 in output is verified deliverable. If there is any change request, you can move it from here, and project management plan, project documents, and organizational process assets will get updated. So the same tools here, all the same tools which we have already studied. Standard deviation I have talked about. These are the percentages of the standard deviation. The little which is not really right in this diagram this is called a bell curve. And bell curve, the only problem with this bell curve is the tails, just let me show you. This is the bell curve. Its shape is like a bell. The bell curve, these ends, this end and that end, the ends are called tails of the bell curve. Tail, the negative tail and the positive tail. Actually, they never touch the base. They will never touch the base. They will keep decreasing towards the base, but will never touch the base infinitely. So the only problem I see in this diagram is that it shows that as if it is touching the base. It is not. It will never touch the base. Anyways, how this bell curve is formed? Basically, this is formed by the public opinion of the people. You see, if you take an opinion from the people, or for that matter, if there is a lot of quality data and you put it all together, you will see that majority of the data will fall between -1 and +1. That's why this is the highest peak point here. The maximum number of defects or maximum number of observations will lie between -1 and +1. And then they will drastically be reduced. So if I have 100 observations, 68.26 observations will fall between -1 and +1. If I take into account a little more area, +2 and -2, that covers 95.46% accuracy. And -3 +3, this is covering 99.73% accuracy. So you decide what level of accuracy do you require. If you are doing a polling or a referendum, then you just need votes more than 50%. 1 sigma or 2 deviation plus minus 1 deviation, which is called 2 standard deviations, or it is also called 1 sigma, is okay with you. You can rely on the result of a referendum based on plus minus 1. But if you want accuracy up to the level of 95.46, you can go up to -2 +2. 99% is normally considered a good figure, which is 99.73, which is even more accurate, is ±3. This is the standard deviation, which is normally considered up to ±3, meaning 3 sigma. But as I was expressing to you, that the Americans have now learned to go beyond 3, and they have now come up to 6 sigma, which is 3.4 defects in a million, which is much more accurate. But still, they fall short of the Japanese concept of 0 defect. So this is the standard deviation. And I don't think we have got anything. So this brings us to the end of the quality management chapter. Any questions or any discussion you want to do? We have some time. Did you have anything?
So the last bit that you have shown, the bell shape.
Last one?
Most of the time, yeah, the last one. But most of the time, we use it as Z test or T test. Is it so? Are we talking about Z test and T test for 6 sigma?
Okay, right. The 6 standard deviations means 3 sigma. Plus minus 3 is the sigma.
3 sigma, okay.
So that would be, if you are talking about 6 sigma, that will be 6 plus and 6 minus. 12 standard deviations is equal to 6 sigma. And the accuracy will be 99.9999 something. You know, that, in other words, 3.4 in a million.
Okay.
So what if this
even better standards? People are even talking about 7 sigma, 8 sigma, 9 sigma, 12 sigma. You know, there are systems like NASA, like nuclear, like fractals, mathematics, where supercomputers are to be used. in those things we need to have accuracies of a very, very high standard. It's not even in millions. It is billions and trillions and zillions. No defects in a zillion. That is something miraculous. So that could be, even more than six sigma. Yes, please.
So how about if the curve is skewed to the right side or to the left side due to the distribution?
Yep.
Then will that justify this plus minus 3, plus minus 2?
Actually, as I said, this line, the tails, are never going to touch the base. They are going beyond the 3, minus 3 and plus 3. And they keep going till infinite. So if we move on to, the next deviation 4 and 5 and 6, the 6 would actually represent that state which brings us to the 6 sigma. So we are trying to improve our accuracy to that level.
Okay, sir.
All right. If there are no more questions, should we finish?
Yes, sir, it's okay.
Okay. I'm thankful to you for being with me today, and let's hope we meet tomorrow again at the same time. Connectivity problems will not be there, inshallah. So let's meet tomorrow.
Inshallah.
Thank you very much and take care. Khudafis.
Allah Hafiz.